Okay, today it is time to look at lesson 69. If everything is going along the way that we had hoped, then today is a block period, and you will be doing both the notes for lesson 69 here in class, as well as the homework. I will walk you through the homework, or you can do it. That depends on what Mrs. Bryden decides for you, if you want to do homework with me or if you want to do it with each other and then check it with me at home. In any case, lesson 69 is about adding and subtracting radical expressions. Okay? So, like radicals have the same radicand and index, unlike radicals have different radicands and or different index numbers. Now, that sounds really complicated, but it's really just complicated in word, not in practice. Okay, so we can think of this the same way we think of any of our like terms. When we have, for instance, the square root of 5 here and the square root of 5 here, these are considered like radicals because I've got 3 square roots of 5 and 6 square roots of 5. They have the same radicand and the same index, and so I can combine them. And I will combine them the same way that I combine any other like terms. So when I go to add 3 square roots of 5 and 6 square roots of 5, how many square roots of 5 do I have altogether? The answer is 9. Right? So 3 square roots of 5 plus 6 more square roots of 5 is going to give me a total of 9 square roots of 5. Let's see if we can do this with subtraction. If I have 7 square roots of AB minus 2 square roots of AB, how many square roots of AB do I have in total? The answer is, right, of these total units of the square root of AB, if I have 7 of them minus 2 of them, then I'll end up with 5 square roots of AB altogether. Okay, so I can add like radicals together. I can combine them, and I do that by combining, either through addition or subtraction, the coefficients. Let's look here. If I've got 8 square roots of 5 and 9 square roots of 7, what do I have altogether? The answer is 8 square roots of 5 and 9 square roots of 7. I cannot combine these because they are not like radicals. Do we see that? Okay, so I don't have the same number in here, which means these are not like terms. So they are as combined as they get. So the answer to this would probably be, if you wrote no solution, in terms of simplifying, or you could simply rewrite it, that the answer is 8 root 5 plus 9 root 7. It is in its simplest form. I cannot combine these anymore because the radicals, these radicands, are unlike each other. Now let's take a look at example letter D. Do I have any like terms here? Remember, I'm looking for like radicals. Here I've got 4 square root of 6r plus 8 square roots of 6r minus 6 square roots of 2s all over 5. Now, I can add and subtract these like normal fractions because the denominators are all the same. Okay, I can do my addition and subtraction straight across the numerators and put 5 in the denominator. Now, is there anything here that I can combine? The answer is yes. I've got 4 square roots of 6r and 8 square roots of 6r. Altogether, that's going to make 12 of them. Minus, because this is negative, so I want to retain that negative, 6 roots of 2s. I couldn't do anything. I can't simplify that any further because they are different radicals, so I cannot combine them. So my answer is simply this. Okay? Now, let's talk about, it gets a little bit trickier. Sometimes it's not immediately apparent whether we can combine radicals if we haven't simplified them. And we did this in a previous lesson, so now we need to bring back that knowledge, okay, and apply it to this lesson here. I can see immediately that I've got square root of 5n and square root of 5n, so I know that these can be combined, right? That that's going to give me 8 square roots of 5n. I can see that immediately. But what about this thing here? Can that be simplified? And the answer is yes. If I look at 20 and I were to do the prime factorization of 20, I know that I would have 4 and 5. And because it's under this square root, I'm taking the square root of this, okay, and I've got n, and n, right? I've got n squared times n that I can pull out of this radical if I were going to simplify it, okay? The square root of 4, I know what that is. That's 2. So I've got 4, leave this alone, times pull 2 out of there. And I can pull out an n, the square root of n squared is n, so I can pull that out. And I have to leave in, so that I got rid of that, I got rid of that. I've got to leave in whatever else is still in here, which happens to be 5n. So I've got 4 times 2n, which is going to give me a total of 8n, 4 times 2n, square root of 5n, plus 5, square root of 5n, plus 3, square root of 5n. And that's all because I simplified what was here underneath that radical. Okay, so now I've got 3 like terms. All of them are the number of a value here, right, of however many square roots of 5n I have. Now, I've got 5 of them here, 3 of them here, and 8n of them there. So guess what, guys? This is as simple as it gets. I cannot add 8n to these because they're not like terms. These would have to have n's. The coefficients here would have to have a variable that was outside of that radicand, and it doesn't. So when I simplify this, it's going to look like this little package here, 8n square root 5n, plus I can combine these two, 5 square root 5n and 3 square root 5n. I can combine those coefficients because those coefficients are just by themselves and they're like terms. And so I get 8 square root of 5n, and that's the answer. Okay? That's as simple as I can make this expression in order to combine all of these. Now, let's see if I can simplify. And I kind of went through here, guys. I know we've done this before, but Mrs. Fairbank's program doesn't allow her to print a whole radicand here, so I just kind of filled them all in there so you could see them. Hopefully you've done that too, and that made sense. But if I want to simplify what's in this radicand here, I need to do the prime factorization. I'm going to do it right here. Of everything underneath that radical. So what is the prime factorization of 48? Okay, what do I have? So I've got, if I were to break this down, I know that 4 times 12 is 48, right? So I know 4 times, and I know that 12 is 4 times 3. I could break this down to 2 and 2 and also 2 and 2. But remember, when I'm simplifying a radical, okay, like this, I take out, the only way I can take a square root is if there's something multiplied by itself that equals this number, and I sure do have that here, don't I? The square root of 4 is 2, and the square root of 4 here is 2. So I pull out a 2, and I pull out another 2. So basically over here I've got 2, that gets rid of this one, times 2, that gets rid of this, and the 3's got to stay in there, okay? And I've got the d right there, square root 3. Okay, so this isn't 22, this is 2 times 2. This is going to end up being 4d square root 3. Okay, let's see if we can simplify our second radicand before we decide if we can combine them or not. Okay, so I need to look at how I would factor. Now, how would I factor 75d cubed? Well, I know that 25 times 3 equals 75, and I can see immediately that I could take the square root of 25, can't I? I just got to leave the 3 in there because I can't do anything further with that. And I've got d squared times d, that equals d cubed. So I know that I can pull out the square root of 25 and I can pull out the square root of d squared, right? So keep that minus in there. That takes the 5 out. The square root of 25 is 5. That's gone. The square root of d squared is d, and still in the radicand is 3d. Okay, 3d. Oh, I forgot that I had a d in here. Did you guys remember that? Did you see that? Were you yelling at me just now? Okay, so there was still a d in there. I forgot about that. This guy, I did the 48 and forgot the d that was in there. I couldn't take this d out because it's just a single d. There'd have to be 2 of them if I was going to take the square root, and there weren't. So I've got a total now, if I simplify this whole mess, right, I've got 4d square root of 3d minus this, minus 5d square root of 3d. Can I combine them? Remember, whatever's in front of that radical has to be the same. They have to be like terms in order for me to combine them, and sure enough, they are. So I've got 4d units of square root of 3d and 5d units, right, minus 5d units of square root of 3d. So altogether, 4d minus 5d is just a minus 1d, or you could just say minus d if you want, of 3d, and that is the square root of 3d. That's my answer. Okay, so that was kind of a lot of work to get there, but we did it. We got there. So that's the simplest form, excuse me, of that expression. This one I think is quite a bit easier, okay, because we have some extremely simple square roots to take, especially those of you are square root champions who have memorized all of these square roots. If you haven't, that's okay too. And we can even look at how to simplify these if we want to. I'll go ahead and do that just for good measure. But we know that the perimeter of a rectangle is all of the sides added together, right? So the length is 6 square root 16, square root of 16, and the width is 3 square root of 121. To find the perimeter, I need 2 lengths and 2 widths, and I add them together, right? So twice the length plus twice the width equals perimeter. Okay, now, can I simplify these before I go trying to combine them? And the answer is yes, 100%, right? I can. So let's look at this first one here, 6 times the square root of 16. I should already have memorized that the square root of 16 is 4, but just in case, let's visualize it. So 16 is the same as 4 times 4. And if I'm taking the square root of something that I'm pulling out, right, it's got to be multiplied by, whatever can be multiplied by itself twice, the square root of that is just a single one of those guys, right? So I've got, this is 6 times 4. So this length right here is simply 24. If I look at 3 times the square root of 121, most of you already know that the square root of 121 is 11, and that's because you know that 11 times 11 equals 121. So if I'm going to simplify, if I'm going to take the square root of something, then I take whatever number multiplied by itself equals the total number in there, which in this case is 11. So this ends up being simply 3 times 11, which equals 33. Okay? So this side is 24, this side is 33. So to find the perimeter, and what are we dealing with? What's our units? Inches. Okay, the length is 24, so I'm going to have 2, and I got 2 of them. So 2 times 24 inches plus 2 times 33 inches is going to equal my perimeter. 2 times 24 is 48. 33 times 2 is 66. Altogether, that gives me a combined total of 114 inches. Okay, that's the perimeter, that's my answer. That one I feel like is fairly simple because of how easy these square roots were to simplify. We see something quite similar here with this rectangular backyard. It's another perimeter problem. The length is 3 times the square root of 625. And the width is 2 times the square root of 256. Now for all of you square root whizzes, okay, you already know that the square root of, let's see, what are we taking here? The square root of 625, is there anybody who just off the top of their heads knows what that is? I bet somebody just said it, right? It's 25. And then does anybody just know off the top of their head what the square root of 256 is? And the answer there is 16. Okay, we could, if you don't have those memorized, you can take all of those factors out Okay, so you could factor 625 and factor 256, and you would find when you did that. Okay, as we factor 625 here, if you needed to, you could pull out a 5, and you could pull out all the numbers, all that kind of stuff. But what you're going to end up with finding in the end is that 625 is the same as 25 times 25. Because those numbers multiplied by each other equal 625, the square root of 625 is one of them. Okay, so it's equivalent to 25. Same thing is happening here with our 256. When you do all of the factoring, you're going to find here, and you can do it multiple ways, but however you need to do it, you're going to end up finding that you've got 16 times 16 equaling 256, which means that the square root of 256 is 16. Okay? So to find the length, now, I'm still not quite done. 3 times the square root of 625. Remember the square root of 625 is 25. So 3 times 25 is 75. And 2 times the square root of 256, which is 16, right? 2 times 16 is going to equal 32. Okay? Because I did 16, pulled out one of those, and you multiply it by 2, because I've got the 2 out here still, and I end up with 32. Again, twice the length, 2 lengths plus 2 widths equals perimeter. Okay, my length here, once I simplified, was 75. 3 times 25 was 75, so I've got 2 of those. Plus 2 times the width, which was, when I finished simplifying, was 32. 2 times 75 is 150. 2 times 32 is 64. And my units here are feet. They're not feet squared, it's not area, it's perimeter, right? So the total perimeter around this rectangular backyard is 214 feet. All right, you guys, before you go on to your practice problems, I think that these were a little too simple and might not totally help you when you get to a problem in your homework or a problem on your test that's a bit more complicated. So don't be upset, but I'm going to have you flip your paper over, and I'm going to give you one more problem that's just a bit trickier, and it's in your book. Okay, so if you want to follow along here with your book, you can, but we're going to find the perimeter of a swimming pool. Okay, so this is your bonus. And yes, I'm going to look for this in your notes on the back of this page, okay, to make sure that you have all of these notes in here. So please follow along with me and write this down as we go. So we want to find the perimeter of a swimming pool. If you want to follow along in your book, this is example 4 on page 451. Again, we've got a rectangle. There's the pool. Okay, and the length is the square root of 800 feet. Okay, and the width is the square root of 648 feet. So I'm going to need 2 of those, 2 lengths, and 2 widths, all of the sides added together, to give me the total perimeter. Okay? Now, I want to simplify these square roots and see, because it's not apparent to me immediately what the square roots of those are. So I need to simplify what's underneath those radicands and see if I can't figure out what the perimeter of this swimming pool is. Now again, we're working with feet. Okay, our unit here is feet. Okay. Let's see if we can simplify the square root of 800. In order to simplify the square root of 800, I need to figure out what, let's just start factoring this. If I end up with 2 numbers that are the same, I can pull one of them outside of this radicand, right? I can actually take the square root of it. So let's figure out what we can do here. So if I divide 800, I immediately see that I can divide it into 2, right? So I'd have 400 times 2, okay? I can't simplify that 2 anymore, but I sure can simplify the 400, because I can see immediately that 20 times 20 is 400, times 2 is going to give me 800. Now check this out, guys. Because I've got two 20s in here, right? 20 times 20, I can take the square root of 400. It's just 20. So it's 20, I pull one of these out, these guys go out of here, and that becomes 20 outside of the radical, times the square root of 2. So I was able to simplify that, okay? Now can I do something similar here with the square root of 648? And the answer, of course, is yes. Of course I can. If I divide 648, okay, by 2, I get 324. 324 times 2. Is there a number multiplied by itself that equals 324? For those of you who have these square roots memorized, you're going to know this. If you need to keep factoring, fine, but I'm just going to let you know right now that 18 times 18 equals 324 times 2. Altogether, that's going to equal 648. Because I have two 18s in here, I can take the square root of 324. It's 18. Times, I can't get rid of that. That's still in there, the square root of 2. Nothing times itself that's apparent to me or obvious to me equals 2. Okay, this is my length. This is my width. Now check this out. I need two lengths, 20 times the square root of 2, plus 20 times the square root of 2, plus two widths, 18 times the square root of 2, plus 18 times the square root of 2. And because these are all alike, I can add all of the coefficients. 20 plus 18 plus 18, right? So 40, 50, 60, 76, when I add all those together, times the square root of 2 feet. That, okay, that gives me now the solution to the perimeter. Okay, there's the solution to the perimeter of my swimming pool. Now I could take that and I could put it back. I could put my simplifications back into my original equation to check my work. And of course you're welcome to do that. But right now I'd like for you to go ahead, please, and work on, you do have some practice problems here on dry erase, A, C, F, and G for lesson 69, and after that should be time to take your 10-minute break, and then we'll come on back into class and work on the homework for lesson 69.